Hi, so in this session I want to discuss polynomial regression. Going back to a linear regression for one input feature, if I consider these two cases, for the first case, if my data looks something similar to this, my best fit line would look similar to this, right? So let's say my score for this is score 1. In the second case, my best fit line might look similar to this, right? Let's say the score is score 2. Obviously, score 1 is going to be higher than score 2, right? Okay. So if I want a higher score in my case 2 as well, what I would ideally want that my algorithm, instead of learning this line, is able to learn a curve, right? Is able to learn a curve. So one way of doing that is polynomial regression. What we do in polynomial regression is, let's say I have this data set x and y. We increase number of features of x, right? In the current case, my hypothesis function would look something similar to this, right? It will be mx plus c, which is always going to be a straight line. But what if I increase one feature, that is x square? For each of the values over here, if I take its square and put it in the x square column, then m1x plus m2x square plus c, right? Which is the equation of a parabola, right? So my algorithm will start to learn curves, right? If I want even more complex functions, what I can do, I can add even more one features, let's say x cube and so on. So this is what polynomial regression is, that we try and add more features of different degrees so that our algorithm is now able to learn curves. So to implement this, I have already imported pandas, numpy and matplotlib. So the file I am using is polydata.csv, and to load my file into my Jupyter notebook, I am using pd.readcsv function. Now dataset will be a data frame. To convert this data frame into a numpy array, I will be using dataset.values function. So dot values is going to convert my data frame into a numpy array. Okay, so dataset is equal to dataset.values. So x will be dataset, all my rows and 0th column, and y will be all my rows and first column. Now if I see the shape of x, it comes to be 10 comma nothing, which means x is a 1D array. But as we have already discussed, sklearn wants our x to be a 2D array, right? So instead of writing over here 0th column, I will write 0 to first column. So it will give me all the values of 0th column, but it will give me of the shape 10 comma 1, right, as we wanted. Okay, so if I see my x, that is 1 2 3 4 5 6 7 10, and my y is this, right? Okay, so if I plot these values on a graph, plt.scatter, so my graph looks something like this. So these are my points. So deliberately I have taken the points which look more like a curve, right? So to add more features to my dataset, that is x square, x cube or any further degrees, I'll be using polynomial features, which is present in the pre-processing module of sklearn. Okay. And I will also import linear regression. Okay, so first we have to make an object of this polynomial features class, and we will have to define what is the degree that we want of our final data set, right? So let me take degree is equal to 2. Then Now my data set will be transformed. Let's say this is my x transformed is equal to poly dot fit transform x. If I see my x transformed, it has transformed into three features, right? So the middle one is our original data set. What it has done is it has squared each value and put it on the right. See, okay. So what it has done, if this was my original x, it has squared each of the value and put it in the x square, and another column has been created of for x0, right? So x0 each will be 1 1 1 1. This is my original values and these are my squared values, right? So if I apply linear regression, let's predict our values using the predict function. So y predict is algorithm dot predict x transformed. Now if I plot these on a graph, first let me scatter my initial data set. Now let me plot my predicted values x comma y predict. Let me give the color as red. Now if I see, instead of getting a line, now my algorithm is able to get a curve, right? So it will give better training score as compared to simple linear regression. Okay, so if we increase the degree, that is if we increase number of features, okay, so I'll get even better score, right? Let's increase more. So we are approaching towards that perfect score. But I hope you realize that this is the training score that we are talking about, right? Score on the training data. We still don't know how well or how bad it is going to perform on the testing data. But on the training data, if we increase the degree, we will be getting better score, right? If I increase this further, straight away instead of 4, I do this 10. Then my curve is near perfect, right? So this is how we can try and achieve better training score using polynomial regression. So in this manner, our algorithm will start to learn curves instead of a simple line, right? So in the next session, I will discuss two very important terms, that is overfitting and regularization. Thank you.